Welcome to day 13 of my Inventor I.O. 30 Days Lost in Space adventure. Upon looking at the calendar recently, I noticed that I'm coming up to the 30th day of having my 30 Days Lost in Space adventure, and had I really been trapped on this alien planet, I think they would have gotten me by now. But anyway, today's lesson just goes a little bit deeper into the functionality of the 4x4 numeric keypad that we have. I've watched the lesson, I've done the code, and like I said in my last video, I wish they would have taken day 13 at a slightly slower pace, only because day 12 and day 11 were fairly simple, and then day 13 just wallops you with a whole bunch of extra stuff. Not that it's difficult, it's just a little bit more painstaking, and you have to really cross your T's and dot your I's to make sure that you get your code just right. So let's go to the computer view and I will show you what I mean. Okay, so we're on the computer screen and we're looking at the code for today's lesson. A lot of the stuff is pretty much the same as the last couple of days. There's the constant byte. There's the pound include keypad.h, constant byte rows equals 4, constant byte cols equals 4. There's a new one, another constant byte called pass length equals 4, which will limit the amount of password characters to 4. Which will limit the amount of password characters to 4. There's a char call, and that variable is called password, and it uses the pass length byte of 4 as the number of maximum characters in the character array. And they set that to a default of 0, 0, 0, 0. Underneath that is the buttons array using rows and cols as the lengths for the two-dimensional array. And none of that is different, it's pretty much all the same. From there we define the row pins and the col pins as the pins that we're using for the input for the row section of the keypad, as well as the column section of the keypad. There we just define the keypad itself as custom keypad, and we use the function settings in keypad.h to make the layout based on this grid pattern here in this character array. Underneath the keypad callout, we create a function called int unlock mode. Inside of there we do a character custom custom key equals custom keypad dot get key, and then we serial print line and then we delay for half a second. Then there's a for statement, and inside of that for statement we declare that I is an integer and it's set to 0, and then while I is less than pass length, do our routine, and then count up I++. And then while custom key equals custom keypad dot get key. And what this is saying is that while the custom key equals custom keypad get key is not active, that's what the exclamation point is for, we're just going to wait on inputs. So all this does is it kind of pauses this function and it just loops continuously right inside of these two curly brackets and just waits for the input from the user. From there we go if password I is not equal to custom key. So this if statement says that if the password that we put in, which is password pass length, this guy here, if this is not equal to custom key, which is custom keypad dot get key, so if the password that we put in is not equal to the keystrokes that are being registered from the keypad, we serial print incorrect password, and then we just print out the custom key or the get key command for the key that was pressed that is incorrect. And with that we return a -1, and we'll use that -1 later in our program to actually see if these conditions were met or not. Underneath that, we serial print the asterisk, and what this does is this will mask the characters that are being put in while we're using the keypad. Here we just do a serial print with double quotes. We print a line, unlock, successful. We return a value of 0, and then from there we exit the function. So if I click on this here, sometimes you'll see it up in the corner here where it shows you that the curly bracket that you're next to is attached to int unlock mode, which is the name of the function, and you'll see in the little rectangle box right here it highlights which curly bracket is tying to which part of the function. So now we get into our setup. And our setup is pretty simple. We're just going serial.begin 9600 for our serial monitor, serial.println press star to set new password, pound to access the system. And then this is where it gets confusing yet again. So we have all this stuff at the top here with our unlock mode function. Then down here, some of it is redundant, I've noticed. But we say char custom key equals custom keypad dot get key. if custom key is equal to star, you get spoiled by that IntelliSense. We'll do an int access equals unlock mode. So inside the loop, we define custom keypad, or custom key with custom keypad get key. And if the key that is being pressed is the asterisk, it goes into the unlock mode function up here. From there, we say if access is less than 0, and this is what I was saying before, if access, which is up here, is returning the -1, because access is now the variable being used to compare the result of unlock mode. So if the return value is -1, we then serial print line access denied. Then we say else serial print line welcome, please enter new password. So again, it checks to see if access is less than 0, and access is being tied to unlock mode function up here. If the return value is -1, it gives the incorrect password call out here. If not, it will return 0 and say unlock is successful. We delay for half a second, and then we go into a for loop, and again we register variable I as an integer equals 0, and then while I is less than pass length, do the function and then count up with I++. I know I'm going to have a curly bracket discrepancy somewhere. And then we do the custom key equals custom keypad dot get key with the not. So while we're not getting keys, we just sit here in this little loop and we wait for input. And then here we're saying that password is equal to custom key, and that we serial print the asterisk to replace the input characters so you don't see it. Yeah, I'm definitely going to have a curly bracket discrepancy somewhere. I can almost guarantee it. So this section here takes in the keypad input. It outputs the 4 stars. And then when you put in the password with custom key, This is the section that actually changes the password. So this is the entering new password. You put in your 4 characters, and then it will register and say password change was successful. And then this section we define, if you press the pound key, again it goes up into the unlock mode function. It checks to see if access is less than 0, and if it is, it says serial print line access denied, else serial print line welcome, you may use the system. So again, there's a lot going on inside of here. Essentially what it's doing is it's just jumping back up into the same function and checking for whether or not the password input was successful or not. And then from there it can continue on and check to see if you can actually access the system or not. I'll compile this to see how much I messed up. It's funny, I made the same mistake the first time I put this in. I missed a curly bracket. I missed the S in buttons. Otherwise, it went through okay. From the looks of the compiled memory, it is a little bit different, so I'm interested to see how it varies from the one that I put in earlier. Let's upload that. Go to the serial monitor. And we get the monitor. It says press star to enter a new password or pound to access the system. I'll press the star key. So it says unlock mode, press password or type password to continue. And I know that it's 0000, but I'll try putting in a 1. And we'll say incorrect password, access is denied. So there I'll go star again, unlock mode, type password to continue. I'll put 0, 0, 0, 0. Unlock successful. Please enter new password. And I'll say 1, 2, 3, and then the letter A. It says that the password change was successful. I probably could have used print lines instead of serial prints. I'll hit the pound key. Unlock mode, type password to continue. 1, 2, 3, 4. So it all seems to be working okay. In the next video, I know that they're going to start tying the buzzer back in so that when you press the buttons, it will register keystroke. And if your password is correct or not, it will either give you a happy sound or a not so happy sound. So I'm interested to see how that all works out. So that will conclude day 13 of the 30 days. Again, there's a lot to go through in here. I'm glad that I was able to key it all in. Again, I actually do have another copy keyed in that I already saved from a few days ago, but it was nice to key it in and then go through it and explain what each of the sections do, just for my own well-being. So again, if you're enjoying the content, please be sure to like and subscribe. Please drop recommendations or comments in the comment section below. If you're interested in the 30 days kit or anything from Inventor.io, check out my affiliate link and my 10% coupon code. Upcoming videos, along with the continuation of the 30 days, because I do have to get through that, will be some additional stuff from Inventor.io. I was picked to be one of the beta testers, so I will be receiving a kit of who-dads and doodads that I can poke and prod and use to my heart's content. So that's going to be part of the video series that I put up here Linux CNC stuff, I'm going to be getting back onto that. I was actually working on my machine the other day, trying to get some analog potentiometers working for not only for myself, but also for another guy that was looking to do the same thing. So I'll be doing a video follow-up on that. If you've been keeping track of my other uploads, I have an EMG Precision tool height setter that I'm eager to get installed on one of my machines so I can test that out. So there's a lot of things in the queue that are coming up. So again, please be sure to like and subscribe. Ring the bell to be notified of all my uploads so you don't miss anything. And man, just have fun and keep learning. We'll see you soon.